So in the calculations phase of a t-test, we get this value of t, and then we need to turn it into a probability or a p-value. And this number here, this 0.065, can be a little bit hard to come by if you don't have technology. But you can still get a very close approximation to that number that it will at least allow us to make a decision on whether to reject or fail to reject. So we have a t of 1.5 with degrees of freedom 39. If we go to our t distribution table, we have degrees of freedom here. So we scroll down degrees of freedom until we get to 39. And unfortunately, this table doesn't have 39. So we're somewhere in between 38 and 40. And we're looking for a t value of 1.5, which is going to be somewhere in between this 1.3 and this 1.6. So back in the days before technology, a lot of time was spent on trying to interpolate a value. Our t is 1.54, which is in here somewhere, and trying to interpolate exactly what the probability would be. But if we scroll back up to the top here, we see that the probability is between 5% and 10%. Now, our actual probability, as we saw before, from technology is 0.06, but the best we're going to get from the table is that our probability is between 0.05 and 0.10. And then we have to multiply that probability by 2. So when we multiply these probabilities by 2, that means we're between 10% and 20%. And notice that our actual p-value of 0.13 is between 10% and 20%. But the point is that if you know that the actual p-value is between 10%, double this, and 20%, double this, if you know the p-value is between 10 and 20, then for sure you're going to reject at alpha equals 0.05, because both ends of that spectrum are greater than 0.05. There's another table that we have over here on the web page that says t-distribution tail areas. So we want degrees of freedom 39, which is again is not going to be on here, but we're going to get close. So we have 35 and 40, and then we're looking over here for a value of t of 1.54. So 1.54 is somewhere between 1.5 and 1.6, and we cruise over here to the region that's about 39 degrees of freedom. So that puts us somewhere in this ballpark here. So our p-value is somewhere between 0.07 and 0.059. So let's say somewhere between 0.06 and 0.07, but that's only for one tail, and our test is a two-tailed test, so we're going to multiply that by 2. And if we take 0.06 and multiply by 2, we get 0.12. If we take 0.07 and multiply by 2, we get 0.14. So our p-value is somewhere between 0.12 and 0.14, and our 0.13 is right there in the middle. So again, we don't have to get necessarily an exact p-value if all we want to know is, are we going to reject? As soon as I see numbers here that are bigger than 0.05, I know I'm going to fail to reject the null hypothesis. So that's how you would figure out an approximate p-value the old school way using a couple of tables.